Hello and welcome back to another episode of Math with Sohn. Today, we are going to be graphing absolute value equations and inequalities. Let's get into it. So, an absolute value equation would have an equal sign, y equals, and typically you just have the absolute value of something like x plus 3, and then maybe let's go with a minus 1. Okay? Now, if you have to graph that, it is in typically this format, where maybe you have a number in front, but we'll deal with that in a minute. And this is what I call change keep format, which is vertex form for a lot of different things, absolute values, square roots, parabolas, a bunch of things. So it's very important that you learn this shape, okay? So you change the sign of the 3 to being a negative 3, and you keep the sign of the negative 1, and you get your vertex. So we are going to plot the point negative 3, negative 1, and then we just have to know what is the basic shape of an absolute value. So the basic shape of an absolute value is a V. We're going to go to the left by 3 and down by 1 because that's our vertex. And we are going to make a V. In order to do this accurately, this number in front is your slope, kind of. I say kind of because it's your slope, but it can't be your slope in general because in one direction it might be the slope, in the other it's like the opposite version of it. So if we are going 1, the number 1 in front means our slope is 1 over 1. If there's nothing there, it's a 1. So we're going to go from here up by 1 and over by 1, and up by 1 and over by 1. And that would be one side of the graph. And the other side, we can't continue this line because it's not a line, it's a V, it's an absolute value. We go up by 1 and over by 1, but in the opposite direction, up by 1 and over by 1 in the opposite direction, and we get our shape. And that's the graph. Now, a lot of teachers will ask you to also state the domain and the range, and the domain for these guys is really easy. It's all real numbers, so you can do that fancy looking R. You could maybe be asked to write it in set notation, which would be negative infinity to positive infinity, or you could be asked to just write out all real numbers. It's up to your teacher. But for the absolute values, the domain is going to be that every single time. The range, however, is a little bit different. It is because the absolute value is a V. It's either going up or down from the vertex, and in this case, it's going up from this point at negative 1. So the range is y is greater than or equal to negative 1, which could be written as negative 1 to positive infinity because it's going up. Not including the infinity means that it's going to be parentheses, but it does include the negative 1, which would be a bracket. So either one of those would be how you would represent the range. So let's graph another one, and let's deal with the slope a little bit differently. So let's say that we have y equals a negative 2. So the slope's going to be negative 2. Absolute value of x, and let's do plus 4. So a lot of thing that makes students nervous is what if there's nothing to change, or what if there's nothing to keep? Well, if there's nothing there, it's 0. So there's nothing to change, and there is something to keep, so this is going to be 0, positive 4. It's not going left or right by anything, but it is going up by 4. So we're going to graph that. 1, 2, 3, 4. And with this being our slope, quote unquote, it's not really a slope, but it acts like it. From this point, we are going to go down by 2 and to the right by 1. And then down by 2 and to the right by 1. And instead of being a V, you get a mountaintop or an upside down V, you may think. And there is your graph. Instead of going up by 1 and over by 1, we go down by 2 and over by 1. And that would work for any slope. If it was negative 2/3, it'd be down 2 over by 3. And that would be how you get it. And you just have to make sure in one direction you do it like a normal line, and in the other direction you just mirror image it. And it faces down because it's negative. So domain is still all real numbers. You can write it as negative infinity to infinity, all real numbers, or the fancy R. I'm just going to stick with the fancy R. The range is not going up this time. This graph is going down, and it's going down from the 4 of our vertex. So that's going to be, you could either write 4 to negative infinity because it is going down, or you could write y is less than or equal to 4. And that would be our range for that absolute value equation. All right, so that's about it. But the next few problems we're going to do, probably just, next two, we will do an absolute value inequality, which doesn't change much. So if you have y is, let's go with less than or equal to, the absolute value of going with, let's go negative x plus 2 minus, plus 3. So it's going to face down because it's negative in front. Change the sign, keep the sign. So far, nothing has changed. The only thing that's going to be different is if it's an inequality, you will have to shade. So left 2, up 3, plotting that point for our vertex. Left by 2, up by 1, 2, 3, dot. Before you draw your V, which in this case is going to be an upside down V, register that this is an equal to sign, so it is going to be solid. If it were not equal to, it would be dotted or dashed. So we are going to go down by 1 and over by 1 because that slope is essentially negative 1 over 1. So from here, down 1, over 1, down 1, over 1, and we can actually fill in that solid line. And then ask ourselves, how is this going to have to be shaded if it is less than? Well, if it's less than, that would mean that I need to shade below this vertex. So directly below this vertex is right here. And it would be everything below the lines that we have drawn as well. And I would be shading that part. And when we do our domain and range for these, we have to also be a little careful. Because if we do our domain and range, the domain's still going to be easy. It's still all real numbers. It's still going to the left and to the right forever. Oh, I'm going to write it out this time. All real numbers. The range is the part where you have to be careful because sometimes the graph is going up, but you're shading down. Sometimes you're going down and you're shading down or shading. You just got to be careful. So is there anything above the vertex, shaded or not? And the answer to that is no, it's blank. It's white up here. So there's no answer or shading or anything above the vertex, and everything is below the vertex. So if everything is below the vertex, it is y is less than or equal to 3. And it's still equal to 3 because it's equal to here. If it wasn't, that wouldn't be an equal sign. So you got to be very careful. You could also write that from negative infinity to 3 including. We're going to deal with another example where it's just slightly different. Maybe instead of it shading down and the graph going down, it'd be going up and up. So I'm going to show you what that looks like. Let's do y is less than a absolute value of x plus 3. So a very basic looking absolute value there. All it has is nothing to change, something to keep, 0, 3. Change keep. Plot that point at 0, 3, up by 3, dot. Your slope is 1 over 1, which is normal. So we're going to go up by 1, over by 1 here. But I can't fill in my absolute value. It has to be dotted or dashed like I have, and up by 1, over by 1 the other direction. The reason it is dashed is because there's no equal to sign. So that's why it's dotted or dashed. I don't know how to spell. Dotted. And now we just have to worry about where are we shading. Well, this one again is less than. If it's less than, we shade below the vertex and below these lines, which means that we're shading down in this case. And if we shade down, because it's less than, if we were shading up, it would have been up here. Just like if we were shading greater than on this one, it would have been up here. So this graph, the range is going to be very different. I hinted at it on the previous problem. Domain, still all real numbers, but the range is funky. Our graph is in fact going up forever, but our shading is going down forever. And if that happens, we end up with a scenario where our graph is going up, but our shading's going down. Now, if you think about that, if something's going up forever and something else is going down forever, you're covering everything. That means that the range for this one is also all real numbers, or from negative infinity to positive infinity. All right? Now, there's one other scenario that I want to briefly go over, and that would be, I'm just going to do it right here in the middle. Let's say y is less than, no, I want to do a greater than. I haven't done one. Greater than, let's do the same exact problem, x plus 3. Graph would look almost the same, except now, when we've done our up 1 over 1 and all that, and we got our v, the exact same v, which way would this one shade? It would shade up. So our shading would be there. What would the range be on that one? The range on that one is different. It's not going into be all real numbers like it was here, because the graph was going up and the shading's going down. Here, the shading is going with the graph. And if the shading goes with the graph, you would assume that it's going to be greater than or equal to 3. But in this case, it's just greater than 3. And you might ask yourself, but why? And that's because this line is dotted. If it's dotted, that means it can't include it. And if it can't include it, it can't be equal to. And you're like, wait a minute, Mr. Sohn. Over here, it's all real numbers. Why did we include it here? And that's because it was eventually filled in with the shading. Even though it was dotted on the line, it was filled in with the shading. So here, it's greater than and not equal to because it never fills in the vertex. So that's why it's slightly different there. All right, that's going to do it for this episode. Until next time, stay positive, and I will see everybody later. Bye.